Ever wonder what it takes to keep you healthy? Like, we're surrounded by germs all the time, right?
It's amazing how well our bodies can deal with them most of the time anyway.
Right. So today, we're going deep on, well, your immune system
Yeah.
and vaccines, which, let's be real, they're kind of a big deal in the whole staying healthy game.
Huge. They're one of the biggest wins in public health ever.
Totally. But okay, before we had like microscopes and labs and all that, how did people explain getting sick?
Oh, man. You'd be surprised.
Because blaming it on bad air or, like evil spirits doesn't really hold up when you're talking bacteria and viruses?
Yeah, no, for sure. The history of medicine, it's got some wild explanations in there. Take the Black Death, right? Imagine Europe, but like back in the 1300s.
Oh, yeah. Wasn't that like a really bad plague or something?
The worst. It wiped out like a third of the entire population. And back then, people thought it was like God's punishment.
Whoa, intense. Good thing we've learned a bit since then.
Yeah.
Speaking of, who were some of the big names that moves things in the right direction?
John Snow and Ignaz Semmelweis, for sure. These guys were like medical detectives before that was even a thing.
Well, like Sherlock Holmes, but for germs?
Kind of, but with fewer deerstalker hats. John Snow, he was a doctor in London, figured out how cholera was spreading.
Cholera. That's a bad one, right?
Oh, yeah, super contagious, can be fatal. Anyway, there was this big outbreak in 1854, and Snow, he's mapping out all the cases. And guess what he finds? A huge bunch of them, all clustered around one water pump.
Wait, seriously, the water was making people sick?
Ding, ding, ding. Contaminated water was the culprit. And Snow's work, it was huge, because back then, nobody thought about that stuff. It really drove home how important clean water is for, well, not dying.
You'd think that'd be obvious, but I guess not always.
Not back then. It was a game changer for public health.
So we've got these microscopic bad guys, the bacteria and viruses making everyone sick. What are they exactly?
Okay, so bacteria, think of them as like tiny single-celled creatures, little factories just churning out stuff.
And sometimes that stuff is toxic, right?
Exactly. But it's not all bad. Tons of bacteria are actually good for us.
Wait, really?
Yeah, like our gut is full of them, helping us digest food, even making vitamins. But then you've got the bad ones, causing like strep throat or food poisoning, not so fun.
So it's like good bacteria, bad bacteria. What about viruses, though? Any good ones there?
Viruses are different. They're way smaller even than bacteria, basically just these little packages of genetic material. And unlike bacteria, they can't survive on their own.
Oh, so they need.
A host. Like they'll invade your cells, take over, and use your own cells to make copies of themselves. Sneaky, right?
Super sneaky. So that's where the immune system comes in, right? To fight off those invaders.
Exactly. The immune system is your body's security detail, working 24/7 to keep you healthy.
It's like a fortress defending against a siege.
Love that. And like any good fortress, your immune system has multiple layers of defense. First up, your skin.
Right. Skin's pretty tough, unless you've got a cut or something.
Exactly. But what about all those other openings, like your eyes, nose, mouth? Those seem kind of vulnerable.
Yeah, good point. Germs could just waltz right in.
That's where mucous membranes come in. They line all those openings, and they trap invaders with, wait for it, mucus.
Mucus. Nice.
Hey, don't underestimate mucus. It's sticky, it traps stuff, and then your body can get rid of it.
Okay, so it's like flypaper for germs.
Pretty much. Your nose, for example, has tiny hairs called cilia that sweep that mucus and all the trapped junk up to your throat where you either cough it out or swallow it.
It's amazing how much is going on that we're totally unaware of. But what if some of those invaders get through our outer defenses? What happens then?
That's when the real action starts. Your inner defenses kick in. We're talking innate and adaptive immune responses.
So like backup arrives.
Exactly. It's actually pretty incredible how it all works. First up, you've got your innate immune system, which is like your rapid response team.
Always ready to roll.
Yeah.
What are they like looking for?
So the innate system, it doesn't target specific invaders. It's more about recognizing things that just don't belong, Common patterns found on pathogens, but not on your own cells.
Okay, so how do they tell the difference?
They've got these special receptors that detect molecules found on pathogens, think like certain proteins or sugars.
So it's like a red flag for the immune system.
You got it. And once those receptors are triggered, whoa, boy, it's game on.
What happens?
The alarm bells are ringing. They release these signaling molecules called cytokines.
Cytokines. Okay, those sound serious. What do they do?
They're like the messengers, rallying the troops. So they're calling in other immune cells to the site of the infection and getting those cells fired up to do their thing.
It's like a microscopic battle going on.
Totally. And one of the big players here is the phagocyte.
Phagocyte. That sounds kind of scary.
They're actually pretty cool. I imagine them as like microscopic garbage trucks going around and just gobbling up anything that looks suspicious.
So they're cleaning up the mess.
Exactly. Destroying those invaders before they can spread. But the innate system, that's just the first line of defense. If the invaders are really stubborn, that's when your body calls in the big guns, the adaptive immune system.
Okay, so if innate is rapid response, adaptive is like special ops.
You got it. This is the branch that learns to target specific invaders. Like, it's building up its own personalized defense system.
That's amazing.
Right. And the key players here are lymphocytes, a type of white blood cell. You've got T cells, which are like the assassins going after infected cells directly. And then you've got B cells, are the ones making antibodies.
Antibodies, that's what vaccines help us create, right?
Exactly. And here's the cool part. This adaptive system, it has memory. So once it encounters a specific invader, like a virus, it creates these memory cells that can remember that invader for years.
Wait, years. So it's like our bodies keep a record of every germ they've ever fought.
Pretty much. Which brings us to vaccines. They basically give your adaptive immune system a sneak peek at the enemy without actually making you sick.
A sneak peek. What do you mean?
Okay, let's rewind for a sec. It's the 1700s, and smallpox is a huge problem. People are dying. It's awful.
Yeah, smallpox. That one was bad news, right?
The worst. But then this doctor, Edward Jenner, he notices something interesting. Milkmaids, the women who milked cows, they were getting cowpox, a milder disease, but related to smallpox, and they seem to be protected from getting smallpox.
So, like, getting a little sick from cows was protecting them.
Exactly. Jenner, he's like, what if I can use this?
And that's how he invented vaccines.
He's considered the father of vaccines, for sure. He took some pus from a cowpox lesion and used it to inoculate this young boy. Then, a few weeks later, he exposed the boy to smallpox.
Oh, man, that's kind of risky. Did it work?
It did. The boy didn't get sick. Jenner had shown that exposure to cowpox could protect against smallpox, and that was huge.
It's amazing how these things get discovered.
Yeah.
So fast forward to today. How do vaccines work now?
We've gotten a lot more sophisticated, but the basic idea is the same. Vaccines today, they contain a weakened or inactive version of the virus or bacteria, or even just a part of its genetic material.
So it's enough for our bodies to recognize it, but not enough to actually make us sick.
Exactly. Your body sees this harmless imposter and is like, hold on, I know you, and it starts mounting that immune response.
Creating those antibodies and memory cells just in case the real deal ever shows up. That's incredible. And it's why vaccines are considered one of the most important public health achievements ever, right?
No doubt. Smallpox is a great example. Before the vaccine, millions were dying from it, but thanks to vaccines, it's completely eradicated. Gone.
That's amazing.
Yeah.
But I know there are people who are hesitant about vaccines.
Yeah, it's true. And it's understandable. People have questions, they hear things, and it can be confusing to know what to believe.
Especially with so much information and misinformation out there.
Exactly. That's why it's so important to be critical thinkers, to evaluate information carefully and not just believe everything we hear.
So how do we do that? How do we know what to trust when it comes to health information?
Good question. Look for credible sources. Peer-reviewed scientific journals, government organizations like the CDC, respected medical professionals, and of course, talk to your doctor.
Solid advice. But what about natural remedies? I mean, our ancestors didn't have vaccines, did they? Didn't they use plants and herbs to stay healthy?
Absolutely. Humans have always turned to nature for healing, and many modern medicines actually have their roots in traditional remedies.
Really?
Like what?
Oh, tons of examples. Aspirin, for one.
Wait, really? Where does that come from?
It's actually derived from salicin, which you find in the bark of willow trees.
Willow trees. Wow, I had no idea.
Yeah. People have been using willow bark for pain relief for centuries.
That's pretty cool. What else is there? I've heard about, like, echinacea and elderberry for colds and flu. Do those actually work?
There's definitely some promising research there, but it's tricky. Just because something is natural doesn't automatically make it safe or effective. Right, there's that whole natural doesn't always equal good for you thing.
Exactly. I mean, think about it. Poison ivy is natural, right?
Okay, good point. So we've got to be careful even with natural stuff.
For sure. Always a good idea to talk to your doctor before you start taking any new supplements or herbal remedies, especially if you're pregnant, breastfeeding, or have any health conditions.
Right. It's always better to be safe than sorry. So we've covered a lot of ground today. Ancient plagues, cutting-edge vaccines, even the power of plants. It all comes back to knowledge, doesn't it? The more you know, the healthier you can be.
Totally agree. Understanding how our bodies work, the amazing things our immune system does, that's empowering.
For sure. Any final words of wisdom for our listeners?
Well, I'd say stay curious, ask questions, dig deeper, and remember, science is always evolving. What we know today might change tomorrow, and that's okay.
It's all part of the process, right?
Exactly. It's a journey of discovery, and that's what makes it so exciting.
Well said. It's been an incredible deep dive into the world of immunity and vaccines. We hope you're feeling informed, empowered, and maybe a little bit in awe of your own amazing immune system.
And maybe even inspired to learn more.
That's what we like to hear. Until next time, stay curious, everyone.